Hello, uh, welcome to today's lesson where we're looking at area of the area of similar shapes. Okay, now it's important that we look at or maybe we talk about what similar shapes are. What are similar shapes? So similar shapes, we're talking about shapes that have got the same angles, like corresponding angles must be equal. But in some shapes, not only must the corresponding angles be equal, even the corresponding sides should be in the same proportion. Okay? Even the corresponding sides should be in the same proportion. That's what we are trying to talk about here. Or maybe let's look at this one. Let's consider these two triangles. Let's consider these two triangles here. Okay? So, if we say this one, this is two, this side is corresponding to this one, all right? Then I can also say maybe this one, let's put this as 3. This is corresponding to this side, and this is like 12, okay? So now, when you look at these two, here, okay? When you look at this one is corresponding to that one, this is corresponding to that. So now, when you get to find out, like I'm trying to show you or to try and get the concept that was being used here, from A to K multiplied by A, from B to K multiplied by B. It appears here, we're talking about like this is corresponding to this one. This is 2 over 6. This is 4 over 12. Now, when you simplify these ones, they'll give us 1 over 3. Even this side we have 1 over 3. Okay? We have 1 over 3, 1 over 3. So you get to discover that it appears this one was multiplied by 3 to come this one. This one was multiplied by 3 to get to that point. So it's like now we have here, in this case, it's like we have 3 outside, then 2. Okay? Here it's like we have 3, then multiplied by what? By this 4. Okay? So in this case, since we are using letters, that is what is happening. But here we have used numbers, and then, so in our case here, it's like 3 is the K there. Okay? 3 is the K there. Now that our concentration is the area, I think that is what I want us to consider the most. So let's come back to this. The two rectangles are similar, and the ratio of corresponding sides being K. Okay, like what I demonstrated there. Now we are looking at the area. Okay, the area of a rectangle is equal to what? Length. Okay, so we multiply B by A here, which is represented by L, which is B, then this one, which is A. So you multiply these ones, these two. Okay, so that is our area. Even this same side, we do the same. Now that here we have our area, this side we have KA, and then here we have, so we are going to say our area is equal to what? AK multiplied by BK. Okay. Now when you multiply this one, you get K squared AB. So this is the area of the first rectangle, and then this one is the area of the second triangle, a rectangle, which can also be written as K squared then AB. This and this are the same. All right. So now, let's get to simplify this, because we are looking at the ratios. We want to get the ratios. So when we are dealing with the ratios, you get to the area of this rectangle divided by the area of the smaller rectangle. The area of the smaller rectangle is this one. The area of the bigger rectangle is this one. So when we simplify this one, this and this one cancel. So we get to remain with K squared there, as you can see. All right. So now we want to get to a point where I'm going to request you to pay attention, because in most cases when we are dealing with the exam, the questions do come and mainly focus on this formula that we are going to talk about here. So now we are saying, in general, if the ratio between the sides of two similar shapes is this one. Now, allow me to wrap this part so that we can use it for okay. So we are saying if in general, if the ratio between the sides of two similar shapes, okay, if the ratio between the two similar sides, okay, I mean the two similar shapes is A over B, or you know this can still be written also as this one, then the ratio between the areas of the shapes is given by this or this. This is very important here. What we are saying is that, okay, if the ratio of the shapes, the ratios of the shapes, you have got 2 and 3. These are the ratios, the original ratios of the shapes that are given. The original ratios of the shapes that are given if you have 2 and 3. Then we are saying, what are the ratios? Please pay attention. What are the ratios of the area? What are the ratios of the area? Because we have the formula now here. We are saying if the ratios, okay, of the sides, if the ratios between the sides of two similar shapes is this one here, then the ratio between the areas, we have to get to square these ones. We have to square these ones. So the ratios of the area, this one is going to be squared and this one also be squared. We square both of them, so we're going to get 4 and 9. These are going to be ratios of what? Their area. Okay? These are going to be the ratios of their area here, as you have seen. Please pay attention there. Because there are times in the exam when they just give you that. And also, if these two are given as ratios of their area, then we want to find now the ratios between the two sides of the two. So we need these, because these are for area. So to go back to these ones, we need to square root them. Then we're going to go back to those ones there. Okay? But the ratios of the area from the original ones here, we need to square them. Then we get to this point. That is very important here. Okay? It's very important. So this is the formula that I want you to master here. If the ratios between the sides of two similar shapes is this one, then for area, you square each one of the ratios. Please, that is very important there. And it will make our work very, very easy. Okay? Make our work very, very easy. So let's look at now the examples here. Let's look at the examples, and I hope we are paying attention. Let's look at the examples. The examples, we have got 2 examples. So, the first one is the 2 triangles below are similar. Okay? Then calculate the area of the bigger triangle. Calculate the area of the bigger triangle. Calculate the area of the bigger triangle. Here, we are given the corresponding side, this one and this one. These are the ratios that we are talking about. Those ratios of A and B. The ratios A and B. It is now these ones that were given. Okay? The ratios A and B, it is these ones now that are given here. These 2. Now, in this case, we are also given the area of a smaller triangle. So the ratios, which is A and B, we have what? 3 and 6. Okay? We have 3 and 6. Now, when we are dealing with area, here. It means we need to use the ratios of area. We need to use the ratios of area. That is very important, like I was explaining. So meaning, if we want to use the ratios of area now, area ratios, okay, we are going to say area ratio, these 2 have to be squared. these two have to be squared. And I'm going to write them in this form. Of course, when you square this one, when you square this, what do you get? You get, this gives you, or maybe it's also important that maybe at this point, just before we go in further, I would love a situation where, just to avoid very big figures, we can simplify this so that we can have 1 to 2. Because we have just simplified them. As the original ratios, we have just simplified them. We have not changed anything. Now we want to go to the area ratios. The area ratio. The area ratio, we said you square these ones now. We need to square these. When you square them, we're going to have 1 over 2. You square. What do you get? 1 over 4. This 1 multiplied by 1, we get 1. 2 multiplied by 2. So this is the ratio for area. This is the ratio for area. 1 over 4. So when we are dealing with area now, because as you can see now, I want to get to a point where we are solving. This one, we cannot have, if you remember the first lesson that we had, you can't have a situation where we have this one. You have got something that is centimeters here, then the other side you have got square centimeter. No, this doesn't work. We need to have the same unit. So that is why we need to change these ratios to the area ratios, like what we have done here by squaring. When we square, then it means we have the ratio for the area. So I simplified them first, then I get to square them. So when you square, this is what we get to have. So now we are getting to a point where we need to solve. So the area ratio here now is, we have 1 over 4. And then the area, remember these have been squared. We have squared these. So the fact that we are squared, it now matches with what we have here because this is squared. So this gives us over, this is what we are looking for here, the area of this one. So it's the question of us, we need to cross multiply. When you cross multiply, you have 1x, or which is just x, then you have got 16. So you get 16 here. So meaning the answer will get to become 16 centimeters squared. This is what is going to be our answer. This is what is going to be our answer here for the first one. This is what is going to be our answer for the first one. So the area, the ratios for area, please, that's very important. So let's look at the second question. Let's look at the second question. Two similar hexagons have corresponding sides of 2 centimeters and 5 centimeters. Two similar hexagons have corresponding sides of 2 centimeters and 5 centimeters. Those the initial ratios. Now find the ratios of their area. I think now this we don't have a problem. Ratios of their area. I told you that now we are going to have the ratios of their area. We square. We square this. What do we get? This gives us what? 4. This one gives us what? 25. These are the ratios of their area. For the first question, that is our answer. It's as simple as that. That is how sometimes it comes in the exam. So we should also be looking at the past papers and what comes there so that we get to familiarize ourselves. Now let's look at the second one. Let's look at the second one. It's like the second one is taking us back. The second one is taking us back to the first question that we had here. Okay? It's like now this one is taking us back to the question that we had here. So now this is it. We have the same ratios. We have the same ratios. We have the same ratios. We already have the ratios of area. When we are talking about area, we need to use the ratios of area. So it means we need to change this one from where they are to the ratios of what? Area. So that is what we are doing here. So we are saying if the area of the bigger hexagon, of course, we know now it goes with this one, and find the area of the smaller. So now, having done this one, so I'm going to come to the second part, which is B. I'm going to have this, like writing it like this. Then this is equals to what? Down here, we need this to be, so this is supposed to be 150, and then this is what we are looking for here. So it's the question of us doing what? We need to cross multiply. How do you cross multiply? We have 25, x is equals to what? 4 multiplied by 150. Okay? Then we say x is equals to 4 multiplied by 150 over 25. All right. So that is what we are trying to talk about here. So we say 4 multiplied by 25 into 150 is what? 6. And this one gives us what? 30 centimeters squared. 25 into this one is, then you multiply, then you get this one as your answer. This is very important, and it's simple for you to practice. So, but we need to do these as many as possible. There could be a number of them that you can practice. But basically, it's a question of the ratios that you're given, then you change them to the ratios of the ratio of the area. Okay? Then when you are talking about area, you do that. You change those initial ratios to the ratios of the area by squaring them. Then you get to... Now, I felt that maybe it's important that I can mention something. I can mention something from the first question. Suppose just as I thought that I should mention, if this one, we found this one as what? I'm taking you back. Then this one was not given. Then now this is the question that they're asking you. Please, can you pay attention, because you may not have. This is what you're not. This thing, such a question can also come in form of where they just give two triangles are similar. The area of the smaller one is this, the bigger, then the side of what, then calculate the side of the one corresponding side of the other, the smaller triangle. So now I just want us to run through in case we have such a question, because we do not have it as one of our examples. Now we already got this as our 16. Now this is what I want us to look at. We know that our answer here is going to be, or should be 3. Okay, should be 3. I just got rid of 3. Let's see if it is going to be the case. So this, we have our areas. This is what? 6 and what? X, I mean. Then here we have what? 4 over 16. Take note of that. Then we can simplify this, and this is, remember, this is area here. So this one we have not squared, so we need to square this one also. We need to square this one here. Okay, we need to square this one because we're talking about area. So we're going to have x squared over 36. Then this gives us what here? 1 over 4. Okay, this gives us 1 over 4. This gives us 1 over 4 this side. I've just simplified it. So at this point, we need to do what? To cross multiply. What do we have? This is our case. Okay? So, then at this point, please, I hope you are following me. It just, now it's like at this point we're getting to equations. But this is what is supposed to be done. Because we didn't have such a question. So you divide by 4. You divide by 4. This cancels. So we have x squared is equals to what? What do we get here? 9. Okay? Then x, we find the root of 9. Okay? So since we are talking about those measurements there, we go for just the positive, which will be 3 centimeters. So you've seen. Take note of that also. You can have such questions. You can have such questions where you're asked to find the other side given the area for both figures. All right, that's very important there. That is very important. So these are things that I felt that you should share. I'll be giving you some practical examples or questions from the past papers. So take note of how I demonstrated here. These are the questions that we're expecting to find in the exam. So there are 2 more lessons to be presented under this topic. And please, let's get to check constantly what is going on in form of what is it that the examiner wants by going through the past papers. Okay? By the end of, after we've done the entire syllabus, we'll be able to, even as we teach, a good number of these questions are coming from the past papers. Some of them, they are textbooks that I'm using, and I can show you those textbooks. One of them is this one. Then we also have Achievers, grade 10, Progress, grade 10, and also past papers. Okay? So, take note of this and this one. This is what I felt that I needed to give you. And I hope you have picked something. Please make sure that you subscribe to my channel. This channel is meant for you. Invite your friends to come. Give us a comment on where we may have not explained better for you to understand on how we can improve. Okay? So, as per tradition, there is a question that I'm supposed to give you. There are questions that I'm supposed to give you as an exercise. I hope you'll be able to see these questions. Have those, you can pause and copy them. I don't have enough space to copy the questions. Let's try to copy these. It's the same thing. It's the same thing that we're supposed to do. This is the last one. There are 2 triangles here. There are 2 triangles here. The one that is the smaller one on top, then the other one, which is the whole thing. Okay, so what you need to find the area of like the second part. You find the area of like the area of the bigger triangle, the area of the smaller triangle. Then you come and subtract the area of a smaller triangle from the area of the bigger triangle. What will remain will be the answer there. Okay, so basically this is what we're expected to find. Thank you so much for watching.